remember, otherwise I've got a problem. In intermediate algebra is that I treat the numerator and denominator separately. So I'm going to create a new fraction, and I have brand new pens now. I have a brand new fraction. And so I'm going to take the numerator first, and put it over a common denominator. And the common denominator is x squared, and remember 4 is really over 1. So I'm going to multiply by x squared over x squared. So this becomes 4x squared plus 1 over x squared. So that's the numerator. Then I'm going to take the denominator, which is 3 minus 1 over x squared. And again, common denominator is x squared. So this is over 1. So this is x squared over x squared. So this becomes 3x squared minus 1 over x squared. And then I'm going to move those two back over. So this becomes 4x squared plus 1 over x squared divided by 3x squared minus 1 over x squared. Now remember, that is a fraction divided by a fraction. So what your goal then is going to be is to invert and multiply, and that you invert the denominator so that you're going to have 4x squared plus 1 over x squared times x squared divided by 3x squared minus 1. The x squareds are going to reduce out, and that gets replaced by 1s. They never go away. It gets replaced by 1. So 4x squared plus 1 times 1 is 4x squared plus 1. And 3x squared minus 1 is just 3x squared minus 1. And then that's your final answer. Now there is a method too, and it's probably one that I use more than what you would use. And I think about it is, suppose that what we have, and you've seen this where a magician has a bunch of stuff on the desk, and then there's, or a table, and then he has a tablecloth, and he takes the tablecloth and he pulls that tablecloth away. Everything stays on the table, but he's got the cloth in his hand. And essentially it's going to be having the fraction essentially collapse on itself. So that means instead of just looking for the numerator and the denominator separately, I'm going to look at finding the LCD of them both. So if you think about, there's a 1 here, a 1 here. And if I look at the denominators, I have a 1, an x plus 1, a 1, and an x. So that in this instance, the LCD is just going to be x times x plus 1. And that's between the numerator and the denominator. In mathematics, whether I'm doing finding common denominators and putting everything over a common denominator, or simplifying something. Multiplying by 1 is an extremely powerful tool. And the one I'm going to choose to multiply by now for the whole problem is going to be x times x plus 1. And it's going to look a little freaky. So I'm going to come back to my problem, and I'm going to treat the numerator as a clump, denominator as a clump. Some of you may have learned this when you took your course in 120. And I'm going to multiply by the LCD, the combined LCD. But this is going to be over 1. This is going to be over 1. Then you say, well, what's that going to do for me? Well, I've got more than one term. I'm going to use a distributive property so that this becomes 1 times x plus 1 minus x times x plus 1. Now remember, this is over 1, and this is over x plus 1. Now notice what's going to happen. The x plus 1s are going to cancel. With the denominator, this becomes 2 over 1, and I think I'm going to do this a little differently. This becomes x times x plus 1 minus x minus 1 over x times x plus 1 over 1, which is what I actually did in the numerator, and I kind of did a little too quickly, sleight of hand. Notice here the x's are going to cancel, so that I'm going to have a 1 there. So what I'm going to end up having is 1 times x plus 1 is just x times x plus 1 minus x plus 1s are going to reduce out. That leaves me a 1 in the denominator. So he has no longer any denominator. So the fraction, top fraction, just collapsed. This is then becomes 2x times x plus 1. Subtract. Now the x's are going to reduce out. And this is x minus 1 times x plus 1. Now I get to simplify the sucker. So the numerator, to me, this is probably not as simple as the top one would have been. This becomes x squared plus x minus x squared. The denominator is 2x squared plus 2x subtract. Well, I've got to do the multiplication first. This is x squared minus 1. Here the x squareds add to 0. So I'm going to have x over, I've got to clean this thing up. This is 2x squared plus 2x minus x squared plus 1. Which is x over 2x squared minus 1x squared is just x squared plus 2x plus 1. And then you could factor that denominator if you wanted to. That's x plus 1, the quantity squared. Now you could have done that problem exactly like I did the one above, which if you go to my note packet online, and this is what my note packet looks like, that's exactly what I did. Then I brought it back over. That was the simplification, inverted and multiplied, and I got the same answer. Either way works, and I don't care which way you use. We'll run into these things at oddball times. You never know when you're going to end up with a complex fraction. It just happens. As you're simplifying something, suddenly something ends up being a complex fraction.